Hello, good day to everyone, and I welcome you to another episode on Moleflow Tips and Workflow. First of all, thank you everyone for your tremendous response and feedback that really encouraged me to create new clips and videos. I hope it is helping you to improve your productivity as well as improve efficiency in day-to-day your work. Today I'm going to talk a little bit about the basics. Yes, what you see on your screen is about the mesh. The reason I have taken up this topic is many a times when I have a conversation with the users, they often come across the situation when they have a symmetric part, but they sometimes the results are not really reflecting minute level, not onto the either side of say of the or RH and LH side of it. So probably we'll learn today how to create actually a symmetric mesh, and probably it could also help you to reduce down your efforts in having a precise results on the either half of the parts. Of course, automation is now coping up very fast, is trying to get the feature geometry as close as possible to the either side of the halves, but I'm still going back to the old school where I'm using it, the something called as a symmetric mesh. I'll show you how to do that, and probably you can try the same thing. But before I go and show the demonstration of it, just want to talk a bit about automation. Is faster, it's user friendly, but often lacks in creating the symmetric mesh. Okay, though the part is symmetric, no option to enforce the symmetric mesh during the mesh generation. There's no way we can do it. It has to be done manually. What's the advantage of having a symmetric mesh? It helps to produce the better flow balance. It also helps to have a uniform pressure and temperature distribution. Please, I'm not saying that the automatic mesh doesn't give the precise results. So this is not really applicable for those parts where the little bit of minute changes are on the either side of it. You can still use the automatic mesh absolutely fine. But if there are, I have seen that user, they really go into depth and really note they want to have very precise results. In that case, probably a symmetric mesh is the way to go forward. I'm going to talk a bit on this part. This looks a little chunkier part, but will be using this part for the for the further mesh refinement as well in the second topic that I'm going to discuss about it. This is a self-generated part, and I thought of discussing today with you. I know it's a simple part, but the objective today is to create a symmetric mesh. This part is symmetric, but naturally it's symmetric on this onto the y-axis also. If I cut across this, it should be symmetric on either side of it. I'll go into the Moleflow and try to create a mesh over here. I have already created, and I'll show it to you. Yes, so I created a dual domain mesh just now, and with the CAD imported, I import usually as a native file format, or try to avoid the step or other format unless until it is not available. So once you have this mesh created with the default setting, you go into the advanced, you'll find it under the mesh tab, and there is something called as a plane cut. Okay, and by default it finds the symmetric plane, irrespective where your origin is, it really cuts into the center. And I can say that keep the triangle on the negative side, else it will keep it onto the positive side. I want to keep it on negative side, so apply it and it cuts it absolutely. And what I'm going to do is that I'm just going to select one element from here, one element, and with the quick selection that is called as a planar triangle, I'm going to delete these triangles which are going to be unsymmetric, since I'm going to reflect on it. I'm going to remove the unwanted properties as well as quickly purge it, the nodes that are left, if at all. I should not, yeah, it is there. Close it and quickly remove the properties. I will on the nodes now, and Control A I selected, Control M, this is a shortcut for the reflection. It will go and reflect the things. Once you have been used to the shortcuts, we really struggle to find it. And then probably I'm going to reflect around the YZ. Okay, yeah, and then I pick up the point over here exactly onto the, you can pick any point onto the edge, that is the mirror edge, and say that attempt to connect the existing model and apply it. You can see that, and I have put it apply the connection to the existing model, so probably you don't really need to look whether the connections has been there or not, but still we will go and do the free edges and look for if at all any free edges are there. Okay, and it shows that no error or no free edges found, so it has completely stick. Now you can see that each and every one, the mesh is completely reflected actually, and this gives the best probability of having a very precise results on the either half of it. It could be a temperature or it could be a pressure. Again, I'm repeating to the earlier statement that automatic mesh still creates and takes into consideration that, but if you are looking at the very minute level, very precise level, then we need to have a exact mesh on the either side of it, right? But I hope that helps. And the second thing that I want to discuss is on to the how precise I can get the sync mark results. Now this part has quite a strong rib over here. I opened this into the Fusion and you can see that this is like it's in 0.052 inches. Let me go and change the units over here, and I will change it from inches to the millimeter, and we will measure it again. Okay, and this is this, and it gives the distance of like 15.8, very thick, absolutely. Yep, and we'll also look for the wall on which it is there. The wall is 16, so it is almost like 1:1, and it is going to create a good sync mark. I need it for that reason. So I imported this part and I created the mesh in the mold flow. I'll show it how does it look like, and this is the baseline, and wow, okay, I don't want to show it this way, and sorry, I created the mesh, and the mesh looks pretty much good. You can see that it has captured the exact that edge reflection onto the either side of it. So I can call this as a side and the B side is this. So I would say that the exactly the edges or the the reflection of the rib has been captured onto the A side of it. Okay, and you can find it the similar way onto the either side of it, and this is done automatically by the software. And when you try to create the mesh into the third party, probably this really the software doesn't understand that there is a rib, and often you missed out of these things. Now this has been absolutely fine. So you'll ask why there is a need. Let's look at the sync mark result over here, as a estimate, and you can get a good sing mark over here actually. Okay, but I am still not happy with the tessellations or the way it has been propagating, or it is been getting diverge. So is there a way, can we improve the quality of the sing mark? Yes. So what I did is that I used the command from here called as a split face. Yes, and you can select the face for which you want to split, and the splitting till should be the edges which you want to select. So you can do the so, and you can have these faces getting splitted, and this can be done very much in the Fusion, and Fusion comes along with your subscription, by the way. If you are not installed, install it and try to make best use of it. Once this is done, I'm going to push the geometry from here itself into the Insight again, and I created the split face or the face split mesh, and let's have a look at it. How does it look like? And now here the elements are much precise. You can see over here, these are the areas particularly which are pretty much very precise. Okay, you can have this exactly cutting, because we have cut the edge face, so there's no element that is going to fall out of this face compared to the earlier one, actually very precise one. And let's look at the sing mark estimate, and now you can see that still it's there, but it is, I'm not still happy with the progress or these things actually. So is there a better way? Again, the question is based as, is there a better way that we can represent it on this one? So what I did it in the other way, in the alternatively, to increase the preciseness of it, I selected the faces. Before the meshing itself, I imported the geometry with the split faces, and I selected this face. Okay, for the guys who are completely new, there is an option that you can select the faces. By default there is a body selection, but if you go in this, there is a face selection. So I would go and select this face or this face, and I have assigned defined the mesh density. I have made sure that for these faces I have assigned the mesh density as 2 and the global edge length is 6, so that gets applicable. So now when you're meshing, you will get a very very dense mesh. You can get it over here. It's capturing the element count. But if you're doing it in dual domain, you are going to lose the mesh match, because it shows the gradual transition from the fine mesh to the coarser mesh. So that causes the reduction into the mesh match. So be careful about it. But if you are doing it into the 3D, there is no question of mesh match. You can use it for that purpose. So I have done it 3D, and I'm going to check the results for it as a sing mark estimate. And now compared to the earlier, it is very sharp now, though there is a little bit of disturbance, but compared to the earlier one, it's very sharp. And what I'm going to do is I'm going to now compare all of these 3 results for your reference. Go into the and I'm going to put it as vertical, yes, and I'm locked the views. Okay, of course the plots are been same, so you can see now which one is much refined. This is the refined, which has a very precise this one. This is not bad, this is also not bad. Those are like baseline, and the split face are almost alike. So there is you can say that the auto meshing is taking care of these things probably not to mesh it, but only in case you need a refinement, then you need a split face, and that's the reason I thought of showing the complete workflow. I hope these two meshing tips would be useful to you and try to implement into your day-to-day analysis work, and this will create a much better precise results than just doing it. Again, I'm saying that repeating myself, auto mesh is good enough, but if you want to go little higher precision, accuracy probably, then think of using these tips. Have a great day ahead. Talk to you soon again. Bye.